This is Common Core State Standard Support Video in Mathematics. The standard is 4.NF.B.4, and we are actually looking at two parts here for this standard, parts A and B. Standard 4.NF.B.4 states, apply and extend previous understandings of multiplication to multiply a fraction by a whole number. Part A states, understand a fraction a over b as a multiple of 1 over b. For example, use a visual fraction model to represent 5 over 4 as the product of 5 times 1/4, recording the conclusion by the equation 5/4 equals 5 times 1 over 4. Part B states, understand a multiple of a over b as a multiple of 1 over b, and use this understanding to multiply a fraction by a whole number. For example, use a visual fraction model to express 3 times 2/5 as 6 times 1/5, recognizing this product as 6 over 5. In general, n times a over b equals to n times a all over b. Let's investigate what standards would be connected to or support standard 4.NF.B.4a. Back in 3rd grade, we had standard 3.NF.A.1 that dealt with understanding a fraction 1 over b as a quantity formed by one part when a whole is partitioned into b equal parts. In grade 4, we also have standard 4.NF.B.3b that deals with decomposing a fraction into a sum of fractions with the same denominator in more than one way. This connects to the standard that we're addressing through this idea of a fraction being a multiple of 1 over b. Let's look at this idea of a fraction, a over b. Let's use the physical representation, a circle. We cut it up into 4 parts, so each one of these would be 1/4. Let's take our standard and replace our variables. We're dealing with fourths, so let's do that. So here we have a fraction 3/4. Each part is 1/4. So let's cut those out and represent them this way. Now let's write it out symbolically. It's a good idea to do this. That way the students can make the connection between the concrete and the abstract. It makes this a lot clearer for students. Now we look at this idea of 3/4 being a multiple of 1/4. Notice here that we have 1/4 plus 1/4 plus 1/4, which is simply 3 times 1/4. The reality is that we do have 3 1/4, but that might be a little bit confusing to students. So traditionally we say 3/4, but still students need to understand that we actually do have 3 1/4. Let's look at this idea of a fraction a over b. We're using the example using fourths. Now this is what would be particularly frustrating for teachers. Students would look at this symbolically and they revert back to what they would learn with whole numbers, and they do this. You really can't blame them because they're used to just adding things up. So they add up the numerators and they figure, well, I need to also add up the denominators. So the confusion here really is the symbolism. What do these numerals really represent? So let's focus again on this idea of a fraction. In this case, okay, we had 3 over 4. What does the 3 represent, the numerator? Well, that's the typical interpretation. That 3 is a quantity. It is an amount. But the trick is the denominator, in this case, a 4. That is really a noun. It's not a quantity like we're used to. And this is a total reversal of what students are used to. Again, the 3 is a number. It is an amount. The 4, on the other hand, it's not really a 4, it's fourths. It is a word. It is a noun. a descriptor of sorts. So this fraction 3 over 4, students really need to see that as 3/4, not as 3 over 4 or anything like that. It's 3/4. By doing that and by writing it out to where students see it in this manner, slowly but surely students should ingrain the idea that 3/4 is no different than 3 dogs, 3 apples, 3 pens. It's the same idea. You have a number at the beginning and then you have a noun following that. We're dealing with 3/4 and we represent the pieces, and then we do our symbolic representation. And here's what students really need to understand. Okay, we're doing the addition, the 1 plus 1 plus 1 in the numerator. No problem, that's our 3. Now we look at the denominators. We don't really have numbers here where we are adding 4 plus 4 plus 4. That is not the case here. Since that's a noun, nothing changes. The 4 remains the same because, again, it's fourths. To help students understand, we should do this. Write it out. 1/4 plus 1/4 plus 1/4. In this manner, they'll see that, okay, I add up the ones, and that's a 3. And then the fourths, those are just words. So nothing changes with that. It's just fourths. So 1/4 plus 1/4 plus 1/4 would be 3/4. So students need to get used to that. I know that this is a little bit repetitive, but this is a very, very important point. By writing it out, students start to understand why things happen the way that they do. If we take 1/4 plus 1/4 plus 1/4 and we write it out in words, it makes it a little bit more obvious that it's really no different than adding 1 apple plus 1 apple plus 1 apple. I have 3 apples. By doing this, you're establishing a parallel with other examples that don't involve fractions, and it starts making a little bit more sense. The fourths is just like apples or some other noun. You don't mess with it. You just add the numerators, and the denominator stays the same because, again, it's not really numbers that you're adding there. Now let's focus on the first part of this standard that deals with understanding a fraction a over b as a multiple of 1 over b. So let's use 7 over 4, and let's break it up into 1 plus 3/4. Now let's change the 1 to 4 over 4. We don't want to just look at the numeric symbolism, so let's do some representation here. Let's split it up. The 4 over 4 will be 1/4 plus 1/4 plus 1/4 plus 1/4, which goes back and connects to that first statement in the standard. Same thing with the 3/4. We split that up to where we have a fraction that's 1 over something. Now we can combine the numerators. We count them up. There's 7 of them. So we have 7/4, which written out symbolically would be 7 times 1/4. Let's focus on the second part that talks about using a visual fraction model to represent something like 5 over 4 as a product 5 times 1/4. So let's do the same example, 7/4. Let's change our 1 to 4 over 4. Let's use a circle and its interior as our model. But let's take that circle and split it up into 4 individual parts like so, to where it's a little bit more obvious to students. Now we have to add the rest of it. So we take a physical representation of 3/4 like so. Let's cut it up to where it's a little bit more obvious. Now we can actually do our addition. We have 1, 2, 3, 4 on the left, and on the right hand of the plus sign we have 3 more, and by counting on we have 5, 6, 7. So we have 7/4, which symbolically, based on what we're trying to do with the standard, would be 7 times 1/4. By using an improper fraction, in this case 7/4, it makes it a little bit more obvious to students that fractions can appear in different forms. They're used to the numerator always being smaller than the denominator, but that's not always the case. Students need to realize that the numerator doesn't have to be smaller than the denominator. And in a case like what we used here, the quantity will be more than 1.